welcome to the part 2 of motion. Last week we said we'll be completing the motion topic this week. Alright, so the point we're going to start today is from the equations of uniformly accelerated motion. We'll be looking at the first equation of motion up to the third equation of motion, how it is being derived. Alright, so let's say that we have the initial velocity of a body moving in a straight line to be u. Okay, so if the initial velocity is u, then we have the final velocity to be v, and the equation and the time of motion to be t. Now acceleration is given as change in velocity over time. Okay, so then we have a, which is the acceleration, to be v minus u all over t. Okay, so if you do cross multiplication, you're going to have at, which is going to be equal to v minus u. Then our v, which is the final velocity, will be at, okay, plus u, or we say u plus at. So the first equation of motion is v equal to u plus a t. Okay, now the second equation of motion, let's s be the distance covered in a time t, and with the initial and final velocity given by u and v respectively. So the u is also the initial velocity, and v is the final velocity. We have a time t, and let s be the distance covered. So the average velocity, as we know, this average velocity will be initial velocity plus final velocity divided by 2. That will be the average velocity. Now from the first equation of motion, we have v. This is v. From the first equation we have v to be this. Now if we substitute that, then we're going to have, this is v, then we're going to have u, which is this one, then plus, we have v, and we say this v is like this. From the first equation of motion, we're going to have u plus at, then all over 2. All right, so now we have u. You have that now to be, if you have this together, this one is going to be 2u, okay, plus 80 over 2. Okay, so if you divide this everything by 2, so divide this by 2 is going to give you a u. Then if you divide this by 2, it's going to give you a half at. All right, so this is the velocity, that is the average velocity. Now the distance covered is average velocity multiplied by time. Okay, because we want to find s, distance covered, and we have this, we already find this as our average velocity times time. All right, so once you do that, you're going to have ut multiplied by ut plus half at squared. All right, so this is the second law of motion. That is second law of motion. S is equal to ut plus half at squared. All right, so we can obtain the third equation of motion if we use both the first and second equation that we have obtained, previously. Now, if we look at this particular one is the first equation, this is the second equation of motion. Now, what do? If you square both sides of equation 1, right, it's going to be this. Just square this one, then square u plus 80, okay, multiplied by u plus 80. If you do that, you are going to have this. Then you have u square plus 2a. If you bring 2a out here, it's common. If you put 2a out here, then you're going to have this as ut, but you're going to have half here, 80 square. So u square plus 2as is going to be v square. All right, so v square is equal to u square plus 2as, which we have u as initial velocity, and v is the final velocity. We have t to be time, s to be distance, and a to be uniform acceleration. So we have v square to be equal to u square plus 2as. All right, also we have s to be average velocity multiplied by time. You remember that average velocity is u plus v, over 2. Okay, then multiply by time. Multiply by time. All right. Also, let's look at these examples. We have a bus traveling at 60 kilometers per hour, accelerate uniformly at 5 meters per second square, calculate its final velocity after 2 minutes. All right, so if a bus is traveling at 60 kilometers per hour, so it means the initial velocity, when we're told, is that the initial velocity of the bus is 60 kilometer per hour. Okay, then it said it then accelerates uniformly at this. So our a, which is the acceleration, is 5 meter per seconds. That's the acceleration. Okay, now calculate its velocity after 2 minutes. Our time is 2 minutes. Okay, so I'm going to calculate its velocity. That is the final velocity. Okay, that's what we say we should calculate. Now, what do? We convert 60 kilometer per hour to meter per second. What you just do is just multiply 60, multiply by 1000. Okay, because it's in hour, then you then do 60 multiplied by 60 to convert it to seconds. So having done that, you're going to get 50 over 3 meter per seconds. Okay, then 2 minutes definitely is 60 seconds. That's 2 times 60, or that's 120 seconds. Then if you put it, because it's the final velocity they say we should find, then this our u, 50 over 3 plus 5, which is the acceleration. Okay, then this is the time. Okay, so once you do that, you're going to have 616 meter per second square. Or you can still convert to kilometer per hour if you want to leave your answer at that. That's 616.7 divided by 1000 this time around, then times 60 times 60. All right, so that is how that is being done. Let's look at another example. We said when the brakes are applied to a moving car traveling at 60 kilometers per hour, that's the initial velocity, it decelerates at a uniform speed rate of 5 meters per second. This is retardation. All right, it decelerates. So that is a negative. That's a negative 5. That's deceleration. Then calculate the time taken to reach a velocity of 30 kilometers per hour. This is the final velocity. Right, get to this final velocity, but we want to calculate the time taken because it decelerates at 5 meter per seconds. So we have our initial velocity to be this, okay, which is kilometer per hour. If you convert that to meter per second, like I said the other previously, 60 multiplied by 1000, that's going to give you this. Okay, then you're going to have the final velocity to be this, convert that one also. The retardation, like I said, is a negative acceleration. That's why it's negative, right? So then put this in the first law of equation. Then you're going to have 5 by 3 over this minus 5t. Then try to bring everything together. Then this one cross to this side going to be negative, and this 25 over 3 is equal to 5t. So our t, if we do the arithmetic, where our t will be 25, if you divide both sides by 5, it's going to be like that. So t is going to be 1.66 seconds. All right. All right, so let's look at these examples. A bus moves from rest, okay, move from rest with a uniform acceleration of 2 meter per second. Move from rest, uniform acceleration of 2 meter per second for the first 10 seconds. Okay, for the first 10 seconds, it then accelerates at a uniform rate of 1 meter per second for another 15 seconds. It continues at a constant speed for 70 seconds and finally comes to rest in 20 seconds at a uniform deceleration. Draw the velocity time graph, and from the graph calculate the total distance traveled, average speed of the whole journey, average retardation as the body is brought to rest, then the maximum speed attained during the motion. This is very simple, and it's something that you don't need to worry so much about. So let me just put it through on what you need to do. Now, from the velocity time graph, this is we said a body moves from rest. Okay, let's look at it again. A body moves from rest with a uniform acceleration of 2 meter per second square. Okay, so it moves from rest. Okay, let's say it moves from rest with a uniform acceleration of 2 meter per second square. Okay, that's it. Now, it moves from rest means that the initial velocity is 0. Okay, then it's for the first 10 seconds, that's the time, 10 seconds. So your v, that's the velocity at 10 seconds, will be u plus at. Okay, and you know that our u is 0 because it's moving from rest. Okay, so we have to assume that the body is at rest because it's moving from rest, then it's stationary. Okay, now plus a, which is the 2 meter per second, multiplied by t, which is the 10. All right, so 20 meter per second, that is the velocity. So now when you are drawing your time, quantity is a velocity time graph. Okay, now you need to find the velocity at the first 10 seconds. So from 0 to 10. So once you draw this, velocity here is going to be what? 20 meter per seconds. And that's why you draw your line OA here. That's what makes you to draw your line OA. Okay, now velocity at B, because after then it's then accelerates at a uniform rate of 1 meter per second for another 15 seconds. So now velocity at B, we're going to have velocity that we're looking for, which is velocity at B. Okay, we're going to have it as velocity at A because that got into this place. Velocity at A, then plus that is A AT. Okay, so we want to calculate the velocity at B. We have velocity at A, which is now going to be our initial velocity. Okay, it's now going to be an initial velocity because it has reached a velocity of 20. Okay, before moving to B. So we have 20 plus the acceleration. We said it's 1 here. So accelerating at 1 meter per second. Then for another 15 seconds. So 1 multiplied by 15. All right. Then we have our velocity at B to be 35 meter per second. So this velocity at B here, okay, which is now 25. Okay, it's 15. 10 plus 25 minus 10, this is 15 here. Okay, that's 15 seconds. That's reached at 35 meter per second. Then we now look at that. It then accelerates. It continues with a constant speed for 70 seconds. So it now move like this, all right, for the next 70 seconds. So if you have 70 to this, you are going to have at 95. Okay, get to this place at 95 seconds. Then it then comes to rest at 20 seconds. So at 20 seconds, come to rest. So then 20 plus this will be 115. Then we then draw the deceleration to come to rest at 20 seconds. All right, so once that is done, you can completely uh, draw your velocity time graph as shown here. Now, we are going to find the total distance traveled. Total distance traveled is from here to this particular place. So the area between O, A, B, C, D is the total distance traveled. That's the distance between O, A, B, C, D. That's the total distance traveled. Now we're going to have our S1. Don't forget what I discussed the other time is that you have your total distance traveled. You can have it as area of trapezium, or you calculate it individually. For example, the area OAG is the area OAG is just a triangle. See it there? There is area OAG. It's a triangle, and you're going to have half. That is half base, half base times height. Okay, and this is it. So and the base here is 10, 0 to 10. Okay, and the height here is 20. All right, so if you don't done that, the area OAG is going to give you 100 meter. Okay, then when you have area GABF is a trapezium, and the trapezium says that half the sum of the two parallel sides times height. Okay, the sum of the two parallel sides. For example, area GABF, we have 20. This particular one is 20. This is the one. This is the one of the parallel side. This is another uh, parallel uh, side, right? This one of the parallel side. This another parallel side. Okay, times the difference of the base. Okay, now you're going to have half. This is 20, and this base is 35. Then multiply by 15, which is this, which is the base. Multiply by 15 here. The difference here, that's 15. Then so you have half. 20 plus 35 multiplied by 15 is going to give you 412 meter per seconds. Then we have another one, which is the area of FBCE. Area of FBCE, which is here, FBCE here. This FBCE is just the area of okay, this FBCE is FBCE, which is the area of the rectangle. Okay, that's the rectangle. All right, so which is now 35. Let's look at that 35 again. That's 35 multiplied by okay, this 35. Okay, this 35 here, this 35, and this place is 70. Okay, 35 multiplied by 70, that's the area of the rectangle. Okay, that area of the rectangle that we're looking for there. Okay, and then you multiply it, it's going to give you 2450 meter. Okay, so then we have another area of triangle, that is ECD. Area of the triangle ECD. Okay, so this is another triangle ECD here, which is also half base times height. This is our base and this is our height. Okay, so that's 20 and the height is 35. Okay, that's another area there that we're going to check. So that is half base times height, and it's going to give us 350 meters. So what we then need to do is to add all the areas that we have calculated there. Then we just add it together, and it's going to give us a total distance of three point, and that's 3,312 uh 0.5 meter, 3,312.5 meter, or you have 3.3125 kilometers. Okay, so that is the total area, that's total distance covered by the body. Now, the average speed, as we're told to calculate in the question, is the distance over time. Average speed is distance over time, and this is your speed that you find out, which is the total distance over time. Average speed is distance over time. Then this distance, then over time, then you have your uh 28.8 meter per second. So what is your retardation? Your retardation is along the CD. Okay, let's look at it. Our retardation of the body is along the CD. Okay, so which we have our is along the CD. This is the retardation. This space is our retardation when the body is decelerating to the ground. So we have our CE, okay, which is our retardation. This is the side we're going. So we have our CE all over ED. Our CE is all over ED. So we're saying that our retardation, this is it, retardation along this is what CE over ED. The CE, the CE is the, let's look at it again. This CE is the velocity here at 35. That's the CE velocity here. Then ED is the time that it's covered to reach the retardation. It took the body 20 seconds to get to the ground floor. But the velocity here, before it starts coming down, is 35 meter per second. Right, so that's why we have our 35. Our 35 here, then all over 20. Don't forget, acceleration is v over t, which is the velocity over time. Acceleration is velocity over time. Then retardation, which is the negative acceleration. Retardation is the velocity over time, and this velocity is the one, before it starts. That's its velocity before it starts decelerating, and this is the 20-second the velocity, after it's. I mean, this is the time that it's used to reach the to take to decelerate. Okay, that is a 1.75 meter per second, and the maximum speed attained. Okay, the maximum speed attained. You can find the maximum speed attained from the graph. Okay, from the graph you see that the maximum speed attained is this. All right, that's the maximum speed. That's the velocity, that the highest velocity attained during the journey. That's the maximum speed it's attained, and the maximum speed is 35. All right. All right, so let us look at motion under gravity, free fall. So when an object is thrown upward, it rises to a particular height and then fall to the ground. But it experiences a retardation due to the gravitational attraction of the Earth. So this gravitational attraction tends to pull the object down. So when an object is thrown upward, it's gradually will be losing its speed as it's moving upward. It will be losing its speed as it's moving upward, and it's going to come to a rest briefly when it gets to a particular height. It's going to come to rest briefly when it comes to a particular height, and it's not going to start falling down freely. It's going to start falling down freely under the action of gravity. But um, when the body is moving upward, it is affected by gravitational pull, and the gravitational the gravity, that's the acceleration due to gravity, when it's moving forward, is a negative minus 9.8 meter per second square. It's negative. But when the body is moving downward, the gravity is 9.8 because it's going to be coming down freely under the action of gravity. So what we're saying is that when the body is thrown upward, it's gradually increasing in speed, but later on, as it's moving upward, you discover that it can move upward more, okay, due to the action of gravitational pull. Then later on it will start, coming down freely. So once it's moving upward, it starts losing its speed gradually. Then it's going to come to a stage up there when it's going to come, to a rest. So the equation under gravity is given as this. We have our velocity to be u plus minus gt. I say we just replace a. We have our normal u plus at, the equation of motion. So this particular is replaced by g, which is the also acceleration due to gravity. So it can actually be plus or minus, based on the calculation we're doing. So v square, this height, this is the maximum height reach, which is ut plus or minus half gt square. Then v square is equal to u square plus 2gh. Okay, so the total distance in the other one, now that's total distance, that's the this distance covered, is the maximum height for motion under gravity. All right, so let's look at an example. A cricket ball is thrown vertically upward with an initial velocity of 40 meters per second. Find its velocity after 3 seconds, the maximum height attained, and time taken to reach it. Then the total time taken for the ball to return to the ground. Again, neglect air resistance. Take g to be 10 meters per second as acceleration due to gravity. Then we're given that our u, which is the initial velocity, is 40 meters per second. Our a, because it's thrown upward, then our a is going to be minus g. Okay, that's minus g. Then the time taken, the velocity, that's the time taken, is after 3 seconds. It said we should find its velocity after 3 seconds. So this is the velocity. This is the time, 3 seconds. Then we use our formula v is equal to u plus at, because we want to calculate the velocity after 3 seconds. So our initial velocity is u, which is 40 minus, because this particular one is negative, going up, minus 10 times 3. So then its velocity after 3 seconds is going to be 10 meter per second. Don't forget its initial velocity is this. And like I said, as it's going upward, it's going to be affected by acceleration due to gravity. And that's why you see that the velocity has reduced from 40 to 10 after 3 seconds. Now, the maximum height reached. Okay. Now, at maximum height, the velocity will be 0. As it's moving upward, the velocity keeps on reducing and reducing. So at the maximum height, when the body actually reach this particular height, the velocity, that's the maximum velocity, is 0. Okay, that's the velocity will be 0. Then we have at maximum height is 0. Then we're going to use, because we want to calculate the maximum height reached. Okay, and our height is here, so we're going to calculate it v square, which is 0 here. Okay, then it's equal to 40 square, which is the initial velocity that we are given, minus 2 multiplied by 10, all right, times height. That is the maximum height reached. Okay, so once you've done that one, you calculate it, you are going to get the maximum height to be 80 meter. Okay, so let us look at the time the time to reach the maximum height. Okay, so we've known that the maximum height reach is 80 meter. All right, so now if you look at this, we'll use that to reach, that's the v. Okay, we're looking at our v. Don't forget that v will be u plus or minus gt. Okay, so the time that it's taken to use maximum, so I will know that at the maximum height our v is 0. Okay, then we have our acceleration due to gravity to be 10. and the time is what we are looking for. So, all right. So when you now have, you have your v, which is equal to u minus gt. All right. So, and don't forget, at that maximum height, we'll try to calculate the time that it takes to reach the maximum height. So the maximum height, we said v is 0. Okay, and our u is given as 40. Because it's moving against the gravity, this one will be minus 10t. All right. So if you don't do that, this is going to be minus 40. It's got to minus 10t. So if you do, t will be what? 40 over 10. That's minus 40 over minus 10. That's cancel out. And that will give you a 4 seconds. So that means the time that it takes to reach the maximum height is 40 seconds. Now let us look at the total time taken for the ball to return to the ground again. Time taken to go up, that is plus the time taken to come down. Now let the time taken to come down to the ground from height be at the total time, let the time taken to come down to the ground from highest point be t. That's total time taken to come down from the highest point. Now at maximum height, we know that it reached 80 meter at maximum height. All right. And don't forget that the initial velocity from the highest point is 0. Okay. Okay. It's reached maximum velocity. The velocity is 0, and it rests for a while, which is initial velocity with 0 before it now start coming to the ground. All right. So we have initial velocity to be 0. Then if you put the 0 in the equation, we have half. This is because it's coming down. Because it's coming down, this particular place, the acceleration due to gravity is actually positive g. Okay, because it's a free fall to the ground. Then we have half multiplied by 10, which is acceleration due to gravity, which we are given, multiplied by t square. In this particular formula. Then we have 80. This one will give us 5t square. So if you do 80 divided by 5, so that will be 80 is equal to 5t square. Okay, and our t square will be 80 over 5. 80 over 5 is 16. Then t will be square root of 16, which is 4. Okay, so that is 4 seconds. So the time taken to come down to the ground from the highest point is 4 seconds. So the total time taken for the ball to return to the ground, total time taken is the time to go up and time to come down. So that means we have 4 seconds going up, then 4 seconds going down. So the total time taken for the ball to return to the ground is 8 seconds. That is the ball going up and the ball return to the ground. So time taken to get to the maximum height is the same time taken to return from that same height to the ground. All right, so in this video, we've been able to uh, look at how to calculate the total distance when we have velocity time graph. We've been able to look at how we can calculate the total distance in case we are given a velocity time graph, you know, like this, like this. Okay, been able to look at that, how we can calculate velocity time graph and all that. Okay, so and what we say is that just as a form of recap, we can do the area of all these shapes because this is a this is a trapezium. Okay, this is a triangle, this is a trapezium. Okay, this is a rectangle, and this is a triangle. Okay, so we can calculate all these areas one by one. This one area of triangle is half base multiplied by height. This trapezium, we can say, the area is half the sum of the two parallel line, that's two parallel line multiplied by height. Okay, in this case, this is two parallel line here, parallel 1, parallel 2, multiplied by this particular height. Then for the area of rectangle, we have length multiplied by breadth. Okay, so we have this particular one, will be from here to here, okay, on our graph. Then you calculate this particular one will be the area, and will be the, that's the velocity, is the maximum height reached here, that's the velocity here, which is from here to here. Then also we look at this particular triangle, which is also half base times height, the way we did to the first one. So these are the ways we can do all of that. And we also say that the sum of all the areas that you've calculated, all the sum here, is the total distance that the body covers to move from this place to the last point. Okay, that's total distance it covers to move from the last, from this particular place to this particular place. Okay, so with this we've come to the end of topic on motion. I hope this has been very informative for you. Okay, if you like this video, please share with your friends, share with your loved ones. We want to hear feedback from you, and we want you to subscribe to our YouTube channel. I want you to put your comments, and we want to hear from you. All right, so I will see you next week. Thanks for watching this video. Bye.